Hello student, I am Nirmala Morade, Department of Mathematics from S.V.K.T College, Devali Camp, Nasik. In today's lecture, we will cover changing variables in double integration from the course Calculus of Several Variables. In last lecture, we studied spherical coordinate system, triple integrals using spherical coordinate system and the related examples. So we know that if P is any point in three-dimensional space with a Cartesian coordinate x, y, z, and let us consider the spherical coordinates rho, theta, phi, where the first spherical coordinate is rho. It is the distance of the point from the origin, so obviously it is positive. Second spherical coordinate is theta. Theta is the angle between the projection of the vector OP in xy plane with the positive direction of x-axis, and third spherical coordinate is phi. It is the angle between the vector OP with the positive direction of z-axis. So it lies between 0 and pi, that is 0 is less than equal phi is less than equal pi. Also we studied the triple integrals using these spherical coordinates. So if the region E is given by set of all rho, theta, phi, set of all triplets rho, theta, phi, where rho A is less than equal rho is less than equal B, alpha is less than equal theta is less than equal beta, and C is less than equal phi is less than equal D. So in this case, the triple integral of f of xy over the region, over the solid region E is same as the triple integration of f of rho sin phi cos theta, rho sin phi sin theta, rho cos phi into rho square sin phi d rho d theta d phi, where rho is varying from A to B, theta varies from alpha to beta, phi varies from C to D. That is when we have to calculate the triple integral using spherical coordinates. First we have to calculate the functional value in terms of rho, theta, phi, that is in terms of spherical coordinates. And then dv is replaced by rho square sin phi d rho d theta d phi. In second case, suppose the region is described in this form, that is the E is described as E is same as the triplet rho, theta, phi, such that alpha is less than equal theta is less than beta, C is less than equal phi is less than D, and rho lies between the two functions of theta and phi, that is g1 theta phi is less than equal rho is less than equal g2, which is a function of theta phi. So in this case, the triple integral of f over E is same as f of rho sin phi cos theta, comma rho sin phi sin theta, rho cos phi into rho square sin phi d phi d theta d psi, where rho varies from function g1 theta phi to g2, psi varies from C to D, and theta varies from alpha to beta. So now in this lecture we are going to study changing variables in double integral, that is substitution method in double integral, Jacobian of the transformation. Also we have studied the examples of double integral using changing variable, that is using substitution method. So already we studied such type of problem, that is change in variable in case of function of single variable. When the integral is complicated, it is not easy to solve directly. So in some cases we use the substitution method in case of single variable. So the goal of substitution is to make the integration, which is a complicated, to make it simplest one. So here also in a function of two variables, The goal of substitution method, that is changing variable, is replace the complicated integral by ones that are easy to calculate. The changing variables accomplish this by simplifying either the integrand or the limit of integration or both. So already we have studied the polar coordinate substitution method, that is we solve the double integration by replacing the xy coordinates, that is the Cartesian coordinate, by the polar one. So polar coordinate substitution is a special type of substitution method. After watching this video, students are able to understand the concept of change of variables, to find the Jacobian of the transformation, as well as students are able to solve the problems of double integrals by using the changing variables or by using the substitution method. So now let us consider what is the changing variables, that is substitution method in double integral. So now for that we consider a region in region G in UV plane. That region is transformed 1:1 into region R, which is in xy plane, by the differential equations of the form x is same as the function of uv, that is here x is f of uv and y is g of uv. So now in this case, then a function f of xy which is defined on region R becomes as a function of uv, that is h of f of uv comma g of uv is defined on region G. So now see the diagram. This is the region G in UV plane, and now using this two transformation or using the transformations, x is equals to g of uv and y is equals to h of uv as shown in the figure into the region R in xy plane. This is a 1:1 correspondence. So now if all the functions involved are continuous here, that is all the functions are involved in the transformation are continuous and have continuous first order partial derivatives, then the integral of h of xy over the region R in xy plane and the integral of h of f of uv comma g of uv over the region G are related by the equation double integration of h of xy dx dy over region R is equal to the double integration of h of f of uv comma g of uv into the absolute value of dabba xy upon dabba uv, it is a determinant, into dv over the region G. Now here dabba xy upon dabba uv is a determinant whose first row is a partial derivatives of x with respect to u and v respectively, and the second row is the partial derivative of y with respect to u and v. So this determinant is called as the Jacobian of the coordinate transformation or Jacobian of the transformation x equals to f of uv and y equals to g of uv. So we have already studied the substitution method, that is double integral by using the polar coordinates. So we know that suppose we consider the point xy in a two-dimensional space. These are called the Cartesian coordinates, and consider its polar coordinates as r theta. So the relation between xy and r theta is given by the equation x equals to r cos theta and y equals to r sin theta. So in this case calculate the Jacobian of the transformation. So dabba xy upon dabba r theta. So here original variables xy and uv are replaced by r and theta. So is a determinant whose first row is partial derivatives of x with respect to r and theta, and second row is partial derivatives of y with respect to r and theta. Now first to obtain the first row of this determinant, differentiate x with respect to r and theta. So derivative of x, that is r cos theta, with respect to r is cos theta, and with respect to theta is r is constant, derivative of cos theta is minus sin theta. So it is minus r sin theta. Okay, now to write the second row, differentiate y with respect to r. So its derivative of y with respect to r is sin theta, and derivative of y with respect to theta is r cos theta. Now just simplify this determinant. So it is same as r cos square theta plus r sin square theta. Now take r as a common. So this determinant is same as r times cos square theta plus sin square theta. So we know that cos square theta plus sin square theta is 1. So this determinant is same as r. So now we replace this in above equation. So the relation between the integral of h over r and the relation between the integral h r cos theta r sin theta over g is given by this equation. Double integration of h of xy dx dy over r is same as the double integration of h r cos theta r sin theta. Now replace the absolute value of the determinant dA by xy upon dA by r theta, now which is r, and we know that r is a distance here, distance of the point from the origin, so it is always positive, and that is why its absolute value is r, so we write r, and into dr d theta as it is over the region G. Now let us consider some examples, evaluate some examples of double integral by using substitution method. So now first example is, okay, first we consider the examples of how to calculate the Jacobian of the transformation, and then we will consider the examples of the double integral by using the substitution method. So this is our first example. Find the Jacobian of dA by xy upon dA by uv for the transformation x is equals to u minus v and y equals to u plus v. Okay, so we have to give an x equals to u minus v. As we know that to calculate the Jacobian, we required partial derivatives of x as well as y with respect to uv, that are simplest one because the functions are very simple here. So first we have to calculate the partial derivative of x with respect to u and v. So now here x is u minus v, so dA by x upon dA by u is 1 and dA by x upon dA by v here should be minus 1. By mistake I have written here plus 1 because our x is u minus v. So partial derivative of x with respect to v is it should be minus 1. So be correct here. Okay, now our y is u plus v. So its partial derivative with respect to u is 1 and with respect to v is also 1. Okay, now just write the definition of dA by x upon dA by xy upon dA by uv, and now put all the values and just simplify it. So the first row of the matrix determinant is 1 minus 1 and second row is 1 1. Now solve these determinants, its value is 1 plus 1, that is 2. So here the required answer is 2. Okay, now let us consider one more example of the Jacobian. This example is different from the first one. So here function is u equals to x square minus y square and v equals to twice xy. This is a transformation. So in previous function we have to given the value of xy in terms of uv. Here we have to given the value of uv in terms of x and y. So now our question is to find the Jacobian of the transformation. Okay, that is in terms of uv also. Okay, so one method is first we have to express xy in terms of uv by solving these two equations. That these two equation means u equals to x square minus y square and v equals to twice xy. So for to calculate dA by xy upon dA by uv, we should either express xy in terms of uv and then by using definition directly we can find its value. Okay, but here we use another method. So in another method, first we have to find dA by uv upon dA by xy, because we have to given the value of u and v in terms of x and y. So write its definition. Now dA by uv upon dA by xy is same as first row is partial derivative of u with respect to x and y, and second row is a partial derivative of v with respect to x and y. Now differentiate u with respect to x. Here u is x square minus y square. So dA by u upon dA by x is 2x and dA by u upon dA by y is minus 2y. Now value of v is twice xy. So differentiate this with respect to x. So we get here dA by v upon dA by x as a 2y and dA by v upon dA by y as a 2x. Okay, so we calculate both the partial derivatives with respect to x and y. To solve the determinant, it is simplest one, just solving we get here 4 times x square plus y square. But our question is, we want to express this determinant or we want to express the Jacobian in terms of uv. Okay, so for that we use one identity, and that identity is x square plus y square bracket square is x square minus y square bracket square plus 2 times xy bracket square. So you can easily check whether this identity is true or not by solving both sides here. Okay, but we know that x square minus y square is u, so put there u, so we get u square, and second we replace twice xy by v, so x square plus y square bracket square becomes u square plus v square. Okay, since we required only x square plus y square, so take the square root of both sides. So x square plus y square is the root of x square u square plus v square. As we know that x square plus y square is always positive, so we get here only positive square root, not the negative one. Now just put this value in above equation, so it becomes dA by uv upon dA by xy is equals to 4 times x square plus y square. Replace x square plus y square by root of u square plus v square, so we get here our required answer. So remember here we want to calculate dA by xy upon dA by uv, but first we have to calculate here dA by uv upon dA by xy. Okay, now to calculate the another value, it is one value, so we use the next result. So the result says that dA by xy upon dA by uv into dA by uv upon dA by xy is equals to 1 if dA by xy upon dA by uv is not equals to 0. Okay, so now using this result, calculate dA by xy upon dA by uv, which is same as 1 upon dA by uv upon dA by xy. So now put the value of dA by uv upon dA by xy. So we get here 1 upon 4 times square root of u square plus v square. Okay, that is in case, suppose we have to given the value of uv in terms of xy. So one method is we have to calculate the Jacobian directly by expressing xy in terms of uv first. Or another method is use the result dA by xy upon dA by uv into dA by uv upon dA by xy is equals to 1. So provided that dA by xy upon dA by uv is not equals to 0. So we have two choices available. So use any one which is the simplest one. Okay. So our next part is actually we have to find the double integrals or evaluate the double integrals by using the substitution method, that is changing variables method. So as we know that the goal of this method is to replace the integral which is complicated one by the simplest integral. So generally we follow the following 4 steps to calculate double integral by using the changing variable or substitution method. The first step is, first we sketch the region R which is in xy plane and identify its boundary. This is our first step. We have to given one integration. So suppose that integration is we can't calculate, or it is not easy to calculate that integration by using direct method. So in that case we will go for the substitution method. So suppose we want to go for the substitution method, then to solve it, first step is sketch the region R in xy plane and identify its boundary. Okay. Second step is find the Jacobian of the transformation. Now third step is find the corresponding boundaries or corresponding UV region G and identify its boundaries. And the last step is we apply the formula double integration of h of xy dx dy over R is same as the integral h of in bracket f of uv comma j of uv over the region G into the absolute value of the Jacobian determinant into du into dv. Actually here when we apply this formula, that is we express our original variables are xy and now we replace these xy variables by using the another variables, that is uv variable. So obviously this integral is replaced by the another one. So for that first we replace or we find the value of h given function in terms of uv. Then write dx dy is replaced by the absolute value of the Jacobian into du dv as well as the region R is replaced by G. Okay. These are the 4 steps we will apply to solving the double integral by using the change of variables. So now let us consider the first example. Okay, this is our problem. Evaluate double integration of 2x minus y upon 2 dx dy where x varies from y by 2 to y by 2 plus 1 and y varies from 0 to 4. By applying the transformation x equals to 2x minus y upon 2 and v equals to y by 2 and integrating over an appropriate region in the UV plane. So now see, this is our example. So we can solve this example by using our regular method also. So in regular method first we have to integrate this with respect to x and then with respect to y. So I think you can easily integrate this with respect to by using our regular method, that is directly also. But now here we have to solve this problem by using the substitution method because we have to given the transformations. Okay. So our first step is we have to already given the transformations. So first step is identify the region R first. Now from the given problem, the region R, that is the region of the integration, is the R, which is the set of all ordered pair xy such that x varies from y by 2 to y by 2 plus 1. Limits are given here. And y varies from 0 to 4, that is 0 is less than equal y is less than equal 4 here. So this is our region R. So now we want to sketch the region R. For that we have to write the boundaries of the region R. So now here in this region R, consider all the equalities. So first equality is here x equals to y by 2. Second equality is x equals to y by 2 plus 1. And third equality is y equals to 4. Next one is y equals, third one is y equals to 0 and next one is y equals to 4. So we can easily check all these are the straight lines and now it is very easy to draw all the straight lines. So draw all these straight lines. So this is the graph of the function. This is the region R. So this is a region R which is a parallelogram which is bounded by the 4 straight lines. Y equals to 0, y equals to 2x minus 2, I just rewrite it, and next y equals to 4, y equals to 2x. So this is our first step, sketch the region R in xy plane. Okay, and these are the boundaries. Sketch as well as write its boundaries. So these are the boundaries of the region R. Our next step is to find the Jacobian of the transformation. Now, so for that, in just see here, we have to given the transformation u equals to 2x minus y upon 2 and v equals to y by 2. So to find the Jacobian, so in this case first we have to solve xy in terms of uv. So now first solve these two equations, u equals to 2x minus y upon 2 and v equals to y by 2 for x and y. So just observe both the equations carefully here. If you observe both the equations carefully, so just adding them, y by 2 gets cancelled. So adding these two equations we get here u plus v equals to x. just add them. And from second equation directly we get the value of y as a twice v. So now first step, to find the Jacobian, either we can find the directly also or express xy in terms of uv. So these are the equations of x and y in terms of uv. To find the Jacobian, first we write its definition. DA by xy upon dA by uv is same as determinant of the matrix whose first row is dA by x upon dA by u, dA by x upon dA by v. Second row is dA by x, dA by y upon dA by u, dA by y upon dA by v. I replace directly here values of y and v. So now evaluate this one. DA by u upon dA by v of u plus v is 1. Again derivative of u plus v with respect to v is 1. See the second row, derivative of twice v with respect to u is 0 because we know that here u and v are the independent variables. So when we find the value of, when we find the partial derivative of u or given function with respect to u, we keep other variable constant. That's why this derivative is 0, and derivative of twice v with respect to v is 2 itself, and solving determinant we will get here value as a 2. So this is our second step to find the Jacobian of the given transformation. Now third step is we draw the region R. So for that we should identify the boundaries of the region R by using the boundaries of the region G by using the boundaries of the region R. So see here. So for that we prepare one table that is easy to write all these equations. So first column is we write xy equation for boundaries of region R, that is just we write the equations of boundaries of region R. So there are 4 boundaries for the region R. First is x equals to y by 2, second is x equals to y by 2 plus 1, and third and fourth. Now using this and using the transformation we write the, or we find the corresponding UV equations for the boundaries of the region G. Okay. So now here x is replaced by, now see first one, the second row of the table, x is y by 2, replace x by u plus v and y by twice v. So just replacing these two values and simplifying, the first equation becomes u equals to 0. Now do the same procedure for the next one. So next one is x equals to y by 2 plus 1. Now we replace x by u plus v and y by twice v. Just simplify this one, we get u equals to 1. So third one is y equals to 0. Replace y by twice v is equals to 0. So v is 0, and similarly we get the last one, that is v equals to 2. So now the first column contains the boundaries of R and the second column contains the corresponding boundaries of region G. So now we sketch this region G. So if you observe all these 4 boundaries of G, or all these are the straight lines, they are parallel to either u axis or v axis, so it is very easy to sketch the region G. Now see in the figure. So this is the region G in UV plane. It is a rectangle. So v varies from 0 to 2 and u varies from 0 to 1. Okay. So see these two diagrams simultaneously. So under this given transformation x equals to u plus v and y equals to twice v, the region G is transformed 1 to 1 into the region R. So now our last step is we have to apply the transformation formula. So now we apply this equation to the given problem. So now first just write the given integration. So given integration. Now next step is we replace the integrand limits in terms of uv, and second form is dx dy is replaced by the absolute value of the Jacobian into du dv. So this integration becomes. So first I replace 2x minus y upon 2, which is v. The next one is determinant of the Jacobian is that is absolute value of the Jacobian is mod 2 into du dv. So u varies from, see the region G carefully, u varies from 0 to 1 and v varies from 0 to 2. So now if you compare both the integrations here, you can observe that the first one is a little bit complicated compared to the second one. So this is one of the most benefit, or this is one of the benefit of the substitution method, that is in change of variable method. It is used to simplify the integration, which is the easiest one. So now to evaluate this integration, first mod 2 is itself a positive, we can write outside the integration. And second, you can observe here the integrand can be written as a product of u and v separately, and that's why this integration can be written in this form. So first we have to write 2 outside, then we take the integration of v separately and then integration of u separately. Why we have to write this? Because here we can, terms of x and y can be written separately as a product of terms of u and product of terms of v. So this is same as, keep this 2 as it is, integration, first integration is integration of dv, v is from 0 to 2. So its integration is v, lower limit is 0, upper limit is 2. Integration of u is u square by 2, right, upper and lower integration, and now just apply upper and lower integration here. So 2 times 2 minus 0 is 0, 2, and I write half outside, u square. So put 1 square minus 0 square, it is also 1. Now it is very simple, you know how to simplify it. So just simplifying, we will get the answer here 2. So my suggestion is to here solve both the integrations. Now I have to solve this integration by using substitution method. So at home try to solve the original integration as it is by direct method and see what will be the changes in both the methods. Okay, now let us consider the another example for more practice. This is our second problem. Evaluate double integration e raised to x plus y upon x minus y dA over R, where R is a trapezoidal region with the vertices 1, 0, 2, 0, 0 minus 2, 0 minus 1. Okay, so now suppose directly we want to evaluate this integration, then just see what happens. So I think it is not so easier to evaluate it. So in this case, try to use the substitution method. We have to not given the substitution, but try to use the substitution method. So for substitution method, first thing is we have to require the transformation. So if you observe the integrand here, region of integration is trapezoidal rule, which is the simplest one, and if you observe the integrand, which is e raised to x plus y upon x minus y dA, and when we integrate it with respect to x and y, so it is not so simple. So this integrand suggests us to use the transformation u equals to x plus y and v equals to x minus y. We can interchange this also. So you can put v equals to x plus y and u as x minus y also. Okay. So we use this transformation. So since we want to solve this integration by using substitution method, so in this case, first our first step is we plot or we sketch the region R in xy plane and identify its boundary first. So already I have given the graph here, see the figure. So in this figure, this is a trapezoid. First I just plot the points. I select the first vertex as a 1, 0, next as a 2, 0, next as a 0, minus 2, and just we joined all these the vertices. So a trapezoidal region, that is R, is here. Okay. But how to write the equations of all these boundaries? We should know the boundaries of the region R also. So now we can clearly see the two boundaries. One of them is the x-axis and another one is the y-axis. So we want to find the other two boundaries, and for that we use the equation of straight line which is passing through the 2 points in xy plane. So now suppose I want to find the boundary which is passing through the point 1, 0 and 0 minus 1. 1 0 and 0 minus 1. So for that we consider the first point x1 y1 as a 1 0, second point x2 y2 as a 0 minus 1, and we know that this is the equation of a straight line passing through the 2 point. X minus x1 upon x2 minus x1 is same as y minus y1 upon y2 minus y1. Now put all the 4 values. So after putting these 4 values and solving, we will get here x minus y is equals to 1 is one boundary of the region R. So use the same method to calculate the other boundaries. So there are 4 boundaries of the region R. First one is the line x equals to 0, line y equals to 0. Next one is x minus y equals to 1, and the last one x minus y is equals to 2. These are the 4 boundaries of the region R. Okay. To continue the problem, we want to solve the Jacobian. So Jacobian of the matrix, for that first we have to solve xy in terms of uv, that are also useful for the next step, that is to determine the boundaries of the region G, and that's why first we solve these two equations, u equals to x plus y and v equals to x minus y for x and y. You just observe both the equations carefully. So commonly these equations are very easy, so just by observation, either adding, subtracting, we will get the answer, or directly also we will get the answer. So now here if you observe them, if you add them, y gets cancelled. So adding these two equations, we get u plus v equals to 2x, and subtracting these two equations, we get u minus v equals to 2y. So here value of x is u upon 2 plus v upon 2, and value of y is u upon 2 minus v by 2. So since we get these two values, we can easily find the Jacobian of the given transformation. So for that, first write the definition. So we know the definition. Now put the value of xy. Now just differentiate this with respect to u and v respectively. So we get this determinant is same as first row is half, second row is half minus half, and solving this we get minus 1 by 4 and minus 1 by 4. Just solve this determinant, so we will get here minus half. Okay, our next step is we want to find the boundaries of the region G. So you can denote this region either by any other notation. I have to denote here the region S. So now first prepare one table, it is easy to see. So in first column we have to write all the boundaries of the region R, which are x equals to 0, y equals to 0, x minus y is 1, and x minus y is equals to 2. Now replace x and y in terms of uv. Now we know that x is u by 2 plus v by 2. So put in first equation x equals to 0, so it becomes u equals to minus v. Okay. So second equation is y equals to 0. We replace here y by u by 2 minus v by 2. Put equals to 0. So just solving we get u equals to v here. Okay, and third one is, see the third row, which is x minus y is equals to 1. So we know that v is equals to 1 here, and as well as the last v is equals to 2. So all these are the simplest equation you can easily solve, or we can easily convert into in terms of uv. The simple logic is we have to given the equation in terms of xy. We know the value of x and y in terms of uv. Just we express these equations in terms of uv. So here we got the boundaries of region G. So our next step is either region G or S. Our next step is we sketch it. So if you observe carefully, all these boundaries are the straight lines. U equals to minus v. It is a straight line bisecting the second and the fourth plane, and u equals to v. It is a straight line bisecting the first and the third quadrant, not a plane, quadrant, and v equals to 1 and v equals to t. These two straight lines are parallel to the u axis. So now it is very simple to draw this figure. It is a region S. See this region S. Since we got the region S here, so last step is we apply the formula. We apply this formula, double integration of h of xy dx dy over r is same as double integration of h of f of uv comma g of uv into absolute value of dA by xy upon dA by uv into du dv over the region G. So for that, first put the value of h here over the region R. Now we replace all xy variables by uv variables here, or we just substitute all the values. So this original integration becomes the is equals to the double integration of u, replace x plus y by u, x minus y by v, so u raised to u by v, into the absolute value of the Jacobian, which is minus half here, into du dv. Observe the region S carefully, and in S u varies from minus v to plus v, and v varies from 1 to 2. This one is directly. So already we know how to, if we know the region which is either type 1 or type 2, how to express is in terms of either type 1 or type 2, and how to write the limits of the integration. So that is simplest one, just put all the values here. So first thing is absolute value of minus half is plus half, so and which is a constant, we write the outside of the integration. And now here integration of limits of u are in terms of v. So first we integrate with respect to u first. So integration of e raised to u upon v with respect to u is e raised to u upon v into v, and apply the upper and lower limit for v. V varies from minus v to plus v, so we just apply here. So after putting, first we apply the upper limit. So if you put u equals to v, so it becomes e only, and minus, put the lower limit, u replaced by minus v, so we get e raised to minus 1. V as it is, dv as it is. Now since e minus e raised to minus 1 is a constant term, write the outside of the integration. So integrand is only v, integrate with respect v with respect to v, so we get v square by 2, apply the upper and lower integration here. So upper integration, upper limit is 2, lower is 1, applying it, simplify it. So our answer is 3 by 4 e minus e raised to minus 1. Actually these steps are very simple, already we have to done the study of this, so now it is not so hard to calculate. So in today's lecture we have studied how to solve the double integral by using the substitution method or changing variable method. The aim of this method is to replace the complicated integration by the simplest one, and for that we use the following steps. So we just summarize all these steps first. The first step is to solve the double integration by using changing variable is we have to given the integrand, we have to given the integration. If it is not possible to solve it directly, or it is complicated to solve it directly, if transformations is given, then doesn't matter. But if it is not given, in that case observe the limits of the integration, observe the function carefully, and using that you can write the appropriate transformations. After writing the appropriate transformations, write the region of integration. So to solve the problem of double integral by using substitution method, first step is we should know the transformation. Then next we generalize if these steps. Then first step is we write the region R, sketch the region R in xy plane and identify its boundaries. Second step is find the corresponding UV boundaries or UV region in the UV plane. Third step is find the Jacobian of the transformations. Now these second and third steps are interchangeable. We can either find Jacobian first and then find the region G. And then last step is apply the transformation, that is write the integration which is in terms of UV, write in terms of which is in terms of xy, we write that is in terms of u and v by using this formula. So these are some problems for your homework. or for your practice. My suggestion is just we have studied only the 4 problems, but all the 4 problems are different. If you study these problems carefully, I think you can able to solve each and every problem, related problem of the transformation or the double integration. So these are the some problems for practice. Okay, these are the additional references for your study. So these both books are very simple and easiest one. Okay, next lecture we will continue the same topic. Actually in this lecture we have studied the changing variables in double integral. So now in next lecture we are going to study, or we will study changing variables in triple integrals and related problems.